This is my project showcase for Games Prototyping 3. I made a weather system. So here in the showcase level there's a floor mesh which has my example material for a snow accumulation template. This includes the nodes needed for snow accumulation to work as well as a base color. As long as these are used and connected to base color, the snow accumulation should work, so the user can change things like normal, roughness, and add their own texture sample, and it should work. For the system itself, once installed by the from the plugin here, they have access to all of the content, and in there they can get the actual blueprints. Once dragged into the world, it will always be at the origin point, and the only amount of setup that they need other than the material is just to set the floor that has the material, and then from that point onwards snow accumulation should work, and then they just have access to changing the different aspects of it. So here you have a variable that allows you to change the sky color depending on what you'd like during when it's sunny and clear, as well as the sky color when it's cloudy. So if I were to make it a darker color and then set the timer to 10, you can see it's updated. And then the fog color for day and night. So here is the current time setup, which is how the time system works. So a lot of the project updates in runtime, and on run it will do a simulation of like a full 24-hour day. So it works similarly to a 24-hour clock. So if you wanted 6 in the morning, you put 6 and you can see the direction of the sun, and then if you wanted 6 PM you'd put 18 and then you see the direction is flipped. Instead of putting something like 10:30 for 10:30 in the morning, you'd put 10.5, which is halfway between 10 and 11, so it's slightly different. Day length, similarly, if you want it to be 30 seconds you put 0.5, but this determines how long it will take for the system to complete a full 24 hours. The system is changed using different variables as well as curves. So here we have 3 major types of curves as well as a bunch of different ones that will change certain values, but they're all one of the 3 core types. So we have float graphs, which I can show using the weather type curve and the rain. So these are similar to float tracks on timelines. They're an XY graph that uses 2 variables. Here, this determines when the sky will turn to its cloudy appearance instead of the clear one, which is useful when rain is about to occur. So when it's at 1, that's when it's cloudy, and when it's at 0, you'll see it's not. The rain timeline is essentially the same graph, except this tells the Niagara particle system that between 10 and 2, so whenever the value is 1 to turn on and then to turn off otherwise. Another one, so for sun intensity, this is a vector curve, so this uses 3 values instead of 2, but they still are plotted on the same XY graph. You'll see that this one is empty. This is sort of like a placeholder, but here is the 2 different states of the sun that are taken and inherited. So this top one here is during the day, so you'll see between noon and 5 PM is where it's its brightest, and then here is during the night time. Because it's not visible, it just sets the brightness much lower. The final one, which I can showcase, is the fog sunny color. So this is a linear color graph. It uses 4 axes to plot RGB and alpha values. You see here it has a similar sort of timeline, except to 0 to 1. This determines the fog color as well as sky color at different times. So you'll see at the beginning and end of a day it's black, so it's night and less visible. You see as it gets to the sunset and sunrise, it becomes this amber color, which you can change by double clicking, or if you right click you can change the time value as well as the color. And then for the remainder of the day it's sky blue. These are updated. This graph at the bottom here is updated in real time, so if you for say wanted to change it so it was green, you'll see the blue here is shot right down and green stays up here, or goes up there, sorry. Those are the three major types of curves, and they all have different things that they can control. As for the user, there is also weather controls, so you can enable or disable different weather types, and also change the aspects of them. So you'll see here the rain has radius, which is how far around the player that the rain component will occur and spread out. Rain direction determines the direction it's falling as well as how it sort of faces, so it can rotate. Rain speed is what multiplies the direction, as it's a vector, so you can scale that up to have the rain downpour a lot faster. The particle density determines how many of the rain particles are spawned in the system, so you can have light rain or really heavy and harsh rain with a lot of rain streaks. There's also you can also change the particle material. I have one that I provide, which is just a default one with a slight emissive, so it's visible. Snow works similarly, except it has a slight sway to it, so instead of one direction it has two, and sort of randomly picks between the two, which will make it sway back and forth. Snow speed works in the same way. Accumulation is a tick box, so you can decide whether you want it or not. The accumulation factor, which I bumped up for demonstration's sake, this is this determines how quickly the snow is built up when it does accumulate, so the higher it is the faster it will turn white. And then also the particle density and snow particle. The accumulation also scales with snow speed, so the faster the snow falls, the quicker it accumulates. Cloud speed determines how quickly the clouds move. And wind. So wind is a way of accessing the Niagara wind force component. This is you can change the direction that the wind will be blowing in, and also the scale that it will increase, or the speed of the particle. The rain and snow have independent variables, but you can turn the global wind on to have them both inherit the same one. Storms, so the storm is a lightning strike that has a slight bloom or exposure to have a flash. You can change the minimum and maximum values for the delay between them, so it'll randomly pick between those two. But that's the last of the weather controls. I'll show a quick demonstration of them working. So you'll see the snow changing in real time, the sky getting darker, rain, the splash and the ripple particles, and a lightning strike there. And also, as the sky gets darker and then the moon comes up, around midnight is when snow occurs. And then it should accumulate. There we go. And then it's quick because I changed the value for it, but becomes white. I don't have rain making the accumulation melt faster, however it does eventually melt. That sort of weather interaction was sort of out of the scope of this project, but as for the blueprint itself, it uses the current time as sort of a value to determine what's happening at all times, as all of the floats use that to determine what's happening. So here it takes the day length in minutes and converts it to an hour, which is used in calculation later. Rain component is attached to the player so that it moves with it to save on rendering a large scale radius of it. Here the different user parameters are given to the Niagara system so they can be updated, so you'll see all of the different things that the user can put in. If I go to the Niagara system you can see all of the different parameters that are updated on this begin player. Then global wind is checked, and depending on whether or not it's on, it'll either use its own variables or the global ones. You'll see as well that the rotation strength and the aerodynamic drag change based on the speed. It's a bit more realistic for the drag to increase as speed increases. However, for the sake of showing how like the violent movement of the particles can change, I decided to reduce it a bit, which, while not realistic, I think is a lot better for usability. Otherwise it's a bit harder to tell that it's happening. Here the snow component is attached and uses a similar system to get the user parameters and feed them to the system, and then again it checks global wind. So here is where 1 hour is used. It determines what the current time is and sets it, as well as make sure that it's within the bounds of 0 and 24. So here it determines where the sun position should be using its length curve and the current time. So it checks what current time is and then looks at the curve to see where it should be, and it does so for the moon as well. And then the update weather function is called. Here is a custom macro I made just to have the lightning delay and then output it, and then this is used to wait between the delay and then when it will strike. So when it strikes, it will get a random location within the periphery of the player by getting its forward and right vector, and then it will move the lightning plane accordingly. It also can change the texture randomly, so here for the sake of demonstration I've just got 2 default materials, but it will randomly select one and then use that. The player could add more if they wanted. Then a timeline is used, so this timeline is the behaviour of the lightning strike itself. The Y is the tiling value of the UV of the texture, so as the lightning occurs, it will slowly start to reveal the strike and then quickly show the rest of the UV and then come back up again, so it sort of animates the strike. It also adds an emissive to it, so as the strike happens, it gets brighter as it's completed and it starts out a bit dimmer. And then also the exposure is changed on the post-process, so it does a quick flash of white and then it goes back to its default value. As for update weather, this is what determines how the weathers interact during the current time. So here it checks the weather type curve, which will be 0 or 1 to determine whether it's cloudy or sunny. It uses the same sort of thing, so it gets the value of the sun intensity curve in the given current time, and then it will send that to the system sun component to become brighter or darker depending, and the moon and sky work off of the same system. Here it checks if the player wants rain, and if they do, it will check the timeline curve for when rain is equal to 1 on the, I believe it's y-axis. So whenever it is 1, it's when it should be activated, and then once it goes back to 0, it will then deactivate it. Storms work the same way, except during it being equal to 1, it will call the delay, which will strike. Snow works the same way, however there's a accumulation check, so it'll check if the user wants it, and if so, it will use the material that it got in the construction script to change the blend bias, which scales, like I said, with snow speed and accumulation factor. And here it will remove the accumulated snow over time as well, but like I said, it doesn't scale, as I thought it would be a little bit more believable for the more that it's accumulated, the longer it takes to get rid of. Fog is similar. It uses default values if it's not enabled, however if it is, it will use its own timelines to determine how dense it is, and also how dense it is depending on altitude. Here it checks for sunrise and sunset, and then it'll turn them on or off, which gives the sort of God ray effect. And also it will change the distribution of the Rayleigh, which changes the atmospheric colour of the sky atmosphere. and here it also will determine the colour depending on whether it's sunny or cloudy, or it will let between them, so there's that nice transition. Again here you get the colour of the fog from the curve, and then it will let between sunny and cloudy so it transitions well. And the final part here is where it gets the cloud reference from the construction script and gets the opacity curve, so it will see how dense the cloud should be. So there's stratus and cumulonimbus clouds, and they have their own vector line to show how they behave. The speed also determines how fast they move, and they get the user parameters and then give them to the cloud component. The construction script is a lot simpler. It just sort of it begins by making sure it's always at the origin, just so that things like the sun and the moon don't move out of where they're meant to be, so it's a bit more believable, and it's locked there so you can't get some sort of unexpected occurrences. Here it also checks that all of these components are valid. This is from when the user would have to supply these themselves, however it still checks for them just in case. Here is where it will actually rotate the sun and moon depending on the value that was calculated in update weather. So this will then use the day length curve to rotate around the world depending on current time. The moon works the exact same way, however it's the opposite. Here is where the dynamic cloud material is created, which is based on the volumetric clouds that I made for this system. So it makes a material instance of that and sets it. And here is where it also gets a reference to the snow material, so it will get the ground, whatever the provided one is, check for its material, and then set the reference of it to snow material so it can be accessed. And then as soon as the system's open, it will also call update weather just to make sure. But as for the blueprints themselves, that is my system. Thank you.